Hi there, in this video I'm going to be making the valves and the springs for the Jerry Howell Farm Boy Hit and Miss engine. Now I've never made any valves or springs before, so it should be really good fun. Okay, so I've decided to make the valves in two bits and silver solder them together. So I'll be making the shaft and I'll be making the head separately. Now I have been practicing or experimenting a bit more with silver solder, and the other day I decided to make the valve rocker arm. There's so many bits and pieces involved in this engine that if I tried to video them all I'd be here for about the next 10 years. But this is what I made. Now what I didn't have was a piece of brass that was wide enough, so what I ended up doing was taking two pieces of this and silver soldering a piece alongside it. And you can't see that, but there's an actual join down the centre of that rocker arm. So it's turned out really well, and I think I'm really starting to get to grips with silver solder. And I did make a bit of a mistake when machining this, and I cut a piece out by mistake about 20 thou deep on this side. So again I decided to put a bit of this brass in there, silver solder it in, and then remachine it. And you can see a fine line where it's joined there, but everywhere else perfect. Okay, so the drawing suggests using stainless steel, but I've not got any stainless steel, but I've got silver steel. And I've actually got silver steel in the right diameter. So this is 1/8 of an inch and this is 3/8 of an inch in diameter. So I'm going to be using that for the shaft. And all I'm going to do is I'm going to use a collet chuck in the lathe, face this end off, cut it down to size or just over size, switch it round in the collet chuck, tidy up the other end, then on the mill I'm going to drill 1/16 of an inch hole at the appropriate place. Then back to the lathe I'm going to again use a collet chuck. I'm going to face this end off. I'm going to drill through with a 1/16 of an inch drill bit, or rather remit to that size. Then cut that off, oversize, and having done that I can then silver solder the two pieces together, then put it back on the lathe in the collet chuck and remachine this head. Okay, so what I've done is use this Stephenson's collet chuck in the vise. And what I need to do is to find the centre of the diameter of this piece of silver steel. It's just gone. So I'll zero the y-axis on the arrow, double check it, just gone. Find the other edge. just gone. So if I now halve the amount I've just found on the arrow, so it's y half of and if I move the y-axis back to position 0, that should give me the centre. I'll lock the y-axis. So what I need to do now is to find this edge here. Just gone. So I'll zero the x-axis, double check it, yeah, and this is 6 millimeters in diameter. So what I'll do is I'll move the x-axis 3 millimeters in, and that will give me the center of the edge. Change the DRO to millimeters, move it in by 3. And lock the x-axis. And zero the x-axis again. So I've moved the x-axis in by 0.132 of an inch. I've put a 3 millimeter end mill in here. Then I'm going to create a little flat on top, and that'll be the position where I need to drill with an 1/8 of an inch drill bit. So I've only taken 1/10 thou off, but I think that'll be just right. Well, it's all getting a little bit tight, but what I've done is I've put this little ER11 collet chuck in the bigger ER25 collet chuck, and I've just put a little centre drill in, so I'm just going to touch it, and then I can drill through with the 1/16 of an inch drill bit. Well, it's the first time I've used this little collet chuck, and it seems to work really well in tight spaces. So I've already faced this off and centre drilled, so now I need to drill with this 3 millimeter drill bit and then ream to 1/8 of an inch. So I'm drilling to a depth so I can get 2 of these heads out of this piece of metal.
Blimey.
Well, so far so good. So all I need to do now is to work out how to hold them so I can silver solder them. So these heads are about 1/10 thou over size. So what I've done is I've just put some little punch marks on the edge at the top, just to stop them from dropping down. So they're about 1/10 thou above the end of the rod. So that should be perfect. So what I've done is I've put plenty of flux on all faces. And I don't know whether you can see it there, there's just a tiny piece of silver solder. So what I'm going to do is heat from the bottom, get that nicely heated up, and then gradually heat up to the top until that flux flows. And it's gone. So now it's time to cut this, I suppose you call it a chamfer, on this valve head, and obviously it needs to be at a 45 degree angle, and it needs to come back from this face here to a distance of 0.4 of an inch. So to measure the 0.4 of an inch, I've set this gauge up on the carriage, and I've set the compound slide to an angle of 45 degrees, and that's how the cutter's set up. So I've put a new tip on. I use these ones for aluminium, and the tip is exactly on the edge, the back edge of the valve head. So I've set the dial gauge on the carriage to 0. I'll move the carriage 1/10 thou to the right, pull this back, and I won't draw the cutter back. So hopefully that's got it. So I reckon about 7 thou to come off the front of the valve head. Wow, they look pretty good. Springs, well, this should be a laugh. So the exhaust spring is supposed to have 6 turns in it a length of 1.05 of an inch, outside diameter of 0.4 of an inch, made out of 0.029 29th thou spring wire. Now all I could get hold of was this wire size 12.5. Looking at the tables, it reckons it's 30 thou, but I reckon using the micrometer is round about 29.4 thou, so I'm pretty close to 29 thou. And the intake spring is made up of 7 turns, same length of 1.05 of an inch, same outside diameter, and made out of spring wire 19 thou, and mine is size 7, which is 18 thou. Both these I got from a harpsichord supplier, Hugh Craig. Well, I must say I'm extremely confused. This is a table in the machinery's handbook, and it tells you the size of the mandrel you should use to turn a spring of a particular size. So the small diameter wire I've got is number 7, and I'm aiming for 0.4 of an inch outside diameter. So this here reckons it should be, the mandrel should be about 0.35 of an inch. However, if I turn it on that, it ends up being massive. So I've due to trial and error, I've now got the mandrel down to 0.25 of an inch. Now this reckons the outside diameter should result in 0.301, but actually it's closer to 0.4. So I'm going to proceed on that basis and use that mandrel and see if I can turn this spring. Now for number 12, I did try turning number 12 on the 0.250 mandrel, and this reckons it should have an outside diameter of 0.336. Now it actually ended up about 0.38. Now I don't know whether that's too small or what. But anyway, I'll proceed on a basis of trial and error. Well, I must say I found that extremely difficult. Goodness knows why the tables didn't sort of equate to reality. But anyway, as you can see, I've had quite a few goes, and I've settled on these two. and fingers crossed we'll be okay. Well, that was right good fun. I'm absolutely delighted with the way these valves have turned out. Never made a valve in my life before, but the seal is superb. I mean, you know, if I test it, nothing coming out. Brilliant. I'm not too sure why I had problems with the size of the mandrel for making these springs. I'm just wondering whether the springs are of a different sort of kind of metal to normal ones. I have no idea. But, you know, I sort of got there in the end. Dimension on the one for the inlet port is slightly oversized, I would say. But, you know, there's considerable difference between the inlet port and the exhaust. Exhaust, a lot of pressure needed there. But, you know, it's even looking the business now. Amazing. So, anyway, I'd like to thank everybody for the help and advice and support provided recently. I've had some absolutely fantastic tips. I'll have to mention some of them in my next video. I've just had a beer to celebrate this because I'm over the moon with it, and my silver soldering worked a treat. So I hope you like it, and I hope to see you later.